Okay, to quantitatively compare, this very, very simple point mass approach could give us an insight about human walking. We can do some analysis. Okay, is there any experimental proof that how human walking's mechanical works related? So previous models are simple, like point mass approach, assuming that it's an instantaneous double support phase occurs. So there's a very large impulsive heel strike impulse and a push-up impulse. So that's why we ignore the gravity. However, for human walking, those double support phase is not instantaneous, right? So your total gait period is something like a single support phase about 20% and double support phase is up to 20. Single support phase is about 70 to 80% of the total time, and double support phase occurs about 20% of the whole gait period. So it's not instantaneous. So what that means is your heel strike impulse, the collision impulse, and the push-up impulse is not impulsive. I mean, very large force within the short amount of time. So since we assume that it's impulsive force, that's why we ignore the gravity effect. But in real, your gravitational impulse is not negligible, right? And then the force amount for the heel strike and the collision and the push-ups are pretty much compatible, the same order with that of the gravitational force. So we should also include the effect for the gravitational impulse to quantitatively analyze the impulse the work and energy. So if you consider the gravitational term, well, luckily your main claim doesn't change. Your ankle is still more efficient than the hip, but the amount was sort of reduced, like from 4 times better to 2 times better. Okay, so still your ankle is more efficient, and then you could find out your optimal push-up impulse from the analysis. Okay, so since this is a function of velocity, you can predict what's gonna be your push-up impulse during walking as a function of speed. And this is how you can predict from the model. Like your push-up will reduce over the speed, and same for your gravity and as a heel strike, and then certain values. Okay, very, very fundamentally analyzed based on the point mass analysis. Interestingly, your experimental data showed experimentally you actually measure the ground reaction force for each foot, stance foot and swing foot, at the trailing leg and leading leg, and you just take the integral to obtain the impulse. Okay, and then if you plot it over the velocity is something like 2.3 is about to run. It's very, very fast walking speed. So those experimental data show the humans are pretty much matched with the mechanically optimal push-up strategy obtained from the point mass analysis. It's really fun, isn't it? Now, let's examine your mechanical work. Mechanical work assumed based on the very, very rough point mass analysis are proportional to the p square and the v square here. So if you just have a formulation for that, it's gonna be v before collision square and alpha square term. And note that your speed is proportional to your step length, and your alpha is length. The angle between the two legs is also proportional to the step length. So it turns out to be your work total mechanical work is gonna be proportional to the L to the fourth. Okay, the step length to the fourth. So there are researchers who are examined their mechanical work during walking at various speed, and found that those mechanical work are very well correlated, regressed with the L to the fourth. Okay, and they even measure the metabolic cost, and then those are pretty much well fitted with the L to the fourth as well. So we can say that, okay, mechanical work are strongly correlated with the metabolic cost, and the simple point mass approach to analyze mechanical work could partially or conceptually or qualitatively supported by the experimental human data, which is fun.